We will start in 1 minute. Today we'll continue in section 2.6. The topic is solving compound inequalities. So we started this yesterday, but we'll start over. Yesterday we covered compound inequalities involving the word and. Now compound inequalities made up of two inequalities connected by the word or will be covered. So this example again, either I will accept an offer to work at Google at an annual salary over $100,000, or I will accept an offer to work at Facebook at an annual salary under $90,000. So we say, to summarize, the salary is either greater than $100,000 or the salary is less than $90,000. Okay, if two inequalities are connected by the word or, then numbers that satisfy either condition are included. Two inequalities connected by the word or means that the union of the two inequalities consists of all numbers that satisfy either condition. And with interval notation, the union symbol is used. It looks like the letter U. It's not really a letter, it's a symbol. Sometimes it's referred to as a cup for the union. So it means that we're combining two sets of numbers. Okay, so we'll write the algebraic notation and the interval notation for the compound inequality above. So let's let S be the salary. So remember what the salary was. The salary will either be greater than $100,000 or the salary will be less than $90,000. And this is the algebraic notation. Okay, so in this case, the word or is used in the algebraic notation. Okay, the interval notation, if S is greater than $100,000, then we write parenthesis 100,000, comma, infinity. And then we have the union symbol. And then if S is less than 90,000, we put a parenthesis, negative infinity, comma, 90,000. Well, you might notice, or you might object to, using this for the salary. I mean, it's pretty clear that a salary isn't going to go to infinity, right? That's just not realistic. And neither is it realistic that the salary will be negative. But if we just look at the inequality by itself, and if we do not take into account the context, then this is the correct interval notation for that set of numbers. This is the interval notation. Okay, so this is I guess an example that the pure mathematics sometimes does not have a counterpart in the real world, but of course, parts of mathematics do have counterparts in the real world. Okay, the following example is a variation of the previous one. So we're going to focus on the words that are used, and then hopefully we will learn how to properly translate the words into mathematical symbols. This one says, Google will pay me at least $100,000 a year, or Facebook will pay me no more than $100,000, or sorry, no more than $90,000. Okay, so this time, if we let S be the salary, if the salary is at least 100,000, then we would write S is greater than or equal to 100,000. And then we write the word or. Facebook will pay me no more than 90,000. So that means it could pay 90,000 or less. So we write S is less than or equal to 90,000. Okay, so for the algebraic notation, this is the algebraic notation. And we'll write the interval notation also. If S is greater than or equal to 100,000, then we put a bracket 100,000, comma, infinity, parenthesis, and then the union symbol. And if S is less than or equal to 90,000, then it's parenthesis, negative infinity, comma, 90,000. And then we put a bracket because of the or equal to part. And this is the interval notation. Okay, let's move on to the next page. Maybe we start with a note. A compound inequality made up of two inequalities connected by the word or may include all real numbers. So the following example will illustrate the foregoing remark. So in this statement, a solution to one problem is a number greater than 5 or a number less than 10. So let's let X be the number. The number that's the solution. So the number says is greater than 5, X is greater than 5, or the number is X is less than 10. Sometimes it helps to sketch a graph of the solution. So we'll plot the numbers 5 and 10. So if x is greater than 5, those are all of the numbers to the right of 5 on the number line. Or x is less than 10, those are the numbers to the left of 10 on the number line. And the union is all of the numbers that are represented in at least one of the two sets. So this graph shows us that all numbers on the number line are solutions. Okay, so you'll have like in the software, you'll have a choice in a case like this. All real numbers are solutions. Or if it's a written test or a quiz, then you would write all real numbers. The interval notation, though, for all real numbers, the interval notation is parenthesis negative infinity, comma, infinity. And that's what the next comment is. The interval notation for all real numbers is parenthesis negative infinity, comma, infinity. Okay, so make sure that you distinguish between the word and the word or when they're used together in inequalities. Okay, we'll practice a few problems. We'll start out with some basic ones. So the directions: write the following compound inequalities using algebraic notation and interval notation. Okay, if a number x is less than 3 or x is greater than 5, well, we should know how to graph these. So let's draw a number line and plot the numbers 3 and 5. If x is less than 3, then on the number line, those are the numbers to the left of 3. The other one, x greater than 5, those are the numbers to the right of 5. And the word is in between is or. So if x is less than 3 or x is greater than 5, this is the graph of that set of numbers. This is the algebraic notation. So there's no more work to do for the algebraic notation. But the interval notation, so the left part of this is negative infinity, comma, 3 parenthesis. Since the word or is used, we used the union symbol. And then the interval notation for x greater than 5 is parenthesis 5, comma, infinity. This is the interval notation. Okay, the next one is also fairly simple. A basic example. X is less than or equal to negative 4, or x is greater than 6. So if we graph this, we plot the numbers -4 and 6. X less than or equal to -4. This time we put a bracket at -4, and we shade the left side. This goes to -infinity. And x greater than 6, we put a parenthesis at 6 and shade the number line to the right. Okay, once again, we begin with the algebraic notation. And the interval notation, well, the left part is represented by -infinity, comma, -4 bracket. Since the word or is used, we use the union symbol, and then x greater than 6, parenthesis 6, comma, infinity. This is the interval notation. Okay, is there any question about knowing the difference between algebraic notation and interval notation? Or does that seem pretty clear to you? Okay. So I know in past semesters, students sometimes have difficulties with it. So I'll just mention the algebraic notation, we always use the variable. The interval notation doesn't include the variable in the set. Okay, the next one is another basic one. X is less than 0 or x is greater than or equal to 10. So we plot the numbers 0 and 10. X is less than 0, so parenthesis at 0 and shade to the left. Or x is greater than or equal to 10, we put a bracket at 10 and shade to the right. And once again, we're starting out with the algebraic notation for this set of numbers. And then the interval notation, the left side is from -infinity to 0, parenthesis. And then the union symbol, that corresponds to the word or in the compound inequality. The union with the set from 10 to infinity, including 10. So we put a bracket 10, comma, infinity. This is the interval notation. Okay, one more pretty basic example, and then we'll get into a few more that are a little bit trickier. Okay, this one's pretty basic. X is less than or equal to -5, or x is greater than or equal to 7. So if you're getting bored, maybe you can see if you can finish it before I do. That might take some of the boredom away. So we graph the solution set, draw the number line, plot the numbers -5 and 7. If x is less than or equal to -5, we put a bracket at -5 and shade to the left. And then or x is greater than or equal to 7, we put a bracket at 7 and shade to the right. We're starting out with the algebraic notation. X is less than or equal to -5, or x is greater than or equal to 7. So this is the algebraic notation. The interval notation, we have negative infinity, comma, -5 bracket. The union symbol corresponds to the word or, and then bracket 7, comma, infinity. This is the interval notation. Okay, let's consider the next one. X is greater than or equal to 2, or X is greater than or equal to 4. So, how do we simplify this? Or another way to say it is, what set of numbers are we going to end up with under these conditions? So a number is in this set if a number satisfies one of the conditions or the other. As long as one of the conditions is satisfied, then the number is in that set. Well, we can graph it to see what we get. Plot the numbers 2 and 4. X is greater than or equal to 2. So those numbers start from 2, and then we go all of the numbers to the right. So from 2 to infinity. The other set, greater than or equal to 4, X is greater than or equal to 4. Well, we put a bracket at 4 and shade everything to the right. So what's the union of those two sets of numbers?
2 and 4.
Well, the union is all of the numbers that are in one set or the other.
So 2.
So it's from 2 to infinity. That's the union. As long as a number is in one of the two sets, then the number is in the union. So if a number is greater than or equal to 2, it's in that set. Well, all of the numbers x greater than or equal to 4 are also in the set greater than or equal to 2. Did that clear it up, or is there still some confusion? So a number x is in this set if it satisfies at least one of the two conditions. So a number x is in a set if it's greater than or equal to 2. But all of the other numbers are already in that set. The numbers that are greater than or equal to 4 are already in the set that are of the numbers greater than or equal to 2. So to simplify this, we just say x is greater than or equal to 2. So this is the answer for the algebraic notation. Okay, because if a number is greater than or equal to 4, it's automatically greater than 2, right? And then the interval notation is just bracket 2, comma, infinity. This is the interval notation. Okay, the next one, x is less than 1 or x is less than 8. So we'll draw a number line, plot the numbers 1 and 8. So a number x is in this set if it satisfies one of those conditions. So the first one, x is in that set if it's less than 1. So all of the numbers to the left of 1. Or a number is in that set if it's to the left of 8 or less than 8. Okay, so how do we simplify the algebraic notation for this one?
X is less than 8.
Yeah, x is less than 8, because if a number is less than 1, it's also less than 8. And the word or, remember what the word or means. So x is less than 8, that's the algebraic notation. And the interval notation, if a number is less than 8, then it's parenthesis negative infinity comma 8 parenthesis. Okay, so the word or means union. It means you're combining all of the numbers that are in the two sets, combining them all into one set. Okay, let's try the next one. X is greater than or equal to 3, or x is less than 5. So boil that down and tell me what the set of numbers that represents. So a number x is in the set if it satisfies one condition or the other.
Would this be where all real numbers are the answer?
All real numbers. Yep. Every real number is in that set. But sometimes it can help to graph. We'll plot the numbers 3 and 5. If x is greater than or equal to 3, those are the numbers from 3 and to the right. And if x is less than 5, those are the numbers just to the that are only to the left of 5 on the number line. But if we combine all of the numbers that are in both sets, then we have all real numbers. So all real numbers. And in interval notation, it's parenthesis negative infinity comma infinity parenthesis. So this is the interval notation. So in the previous example, I failed to label this as the interval notation. Okay, now we'll look at some examples that are, there will be a little bit more work to do. You solve the following compound inequalities. Write the solutions in algebraic and interval notations. So if we solve each of the two inequalities for x, then what we will be left with will be a problem similar to the examples that we just went through. So now we have to be careful with the algebra and the arithmetic. So let's begin with this one. X divided by 4 plus 4 is less than or equal to 3, or negative x plus 2 is less than or equal to 2. So solve each of those two inequalities for x. The one on the left, we can start by subtracting 4, and we get x divided by 4 is less than or equal to negative 1. And we'll get started with the one on the right. We start out with negative x plus 2 is less than or equal to 2, so subtract 2 from both sides, and we get negative x is less than or equal to 0. On the left, what should we do? So to solve x over 4 less than or equal to negative 1, we can multiply both sides by 4. Okay, I'll go ahead and put a little bit of detail into it. We're going to multiply by 4 on both sides. Four over 1 times x over 4 is just x, and the the right hand side is negative 4. And the inequality on the right, negative x is less than or equal to 0. When we solve that for x, what do we get? We can divide both sides by negative 1 and switch the inequality to its opposite. So negative x divided by negative 1 is x. 0 divided by negative 1 is 0. But since we're dividing by 0, we have to switch the inequality symbol from less than or equal to greater than or equal. Okay, so now we can proceed. Let's graph the solution set. Plot the numbers negative 4 and 0. If x is less than or equal to negative 4, we put a bracket at 4 and shade to the left. If x is greater than or equal to 0, we put a bracket at 0 and shade to the right. The algebraic notation is, we've already found that. I'll go ahead and rewrite it, the algebraic notation. The algebraic notation for the solution is x less than or equal to negative 4, or x is greater than or equal to 0. And then the interval notation so the interval notation, parenthesis, negative infinity, comma, negative 4, bracket, union symbol, bracket, 0, comma, infinity. So the three ways to display the solutions might be clear to you, but if not, work on learning how to identify one with the other two. So to me, they all look pretty similar, just different ways to display the solution. Okay, let's do the next example. X plus 6 is greater than or equal to 3, or negative 4x plus 3 is greater than negative 1. So first we solve each of the two inequalities for x. On the left-hand side, if x plus 6 is greater than or equal to 3, subtract 6 from both sides, and we get x is greater than or equal to negative 3. And then the word or. Negative 4x plus 3 is greater than negative 1. So this time we subtract 3 from both sides. And we get negative 4x is greater than negative 4. X is greater than or equal to negative 3, or what do we get when we solve the inequality on the right? So if you're watching online, you can type in the answer.
X is less than 1.
Yes, it's going to be x is less than 1. We divide both sides by negative 4. So negative 4x divided by negative 4 is x, or 1x. Negative 4 divided by negative 4 is positive 1, but since we're dividing by a negative, we have to change the inequality from greater than to less than. Okay, let's go ahead and graph the solution set. Plot the numbers negative 3 and 1. Negative 3 is to the left of 1. Hey, if x is greater than or equal to negative 3, it's from negative 3 and to the right. And if x is less than 1, those are the numbers to the left of 1 on the number line. Okay, so the solution is the set of numbers that is in at least one of the two sets. So what's the solution set? Yeah, all real numbers are solutions. As long as a number is in one of the two sets, then it's a solution. But all real numbers are accounted for. Okay, so all real numbers are solutions. The interval notation for all real numbers, parenthesis, negative infinity, comma, infinity, parenthesis. Okay, the next example. So I'll give you a couple of minutes to work on this one. And if you want to type in the answer, you can. So we'll compare notes in a couple minutes. Well, it's been a couple of minutes. What did you end up with?
For the algebraic notation, I got x is less than or equal to 8.
Okay. Well, let's do this. So first, solve each of those inequalities for x. On the left, we start by subtracting 2. So we get x over 5 is less than or equal to 1. And let's start working on the other side. We start with negative x plus 14 is greater than or equal to 6. So subtract 14 from both sides. We get negative x is greater than or equal to negative 8. Then in the next line, if x divided by 5 is less than or equal to 1, multiply both sides by 5, and we get x is less than or equal to 5. And then, or for the other one, negative x is greater than or equal to negative 8. Divide both sides by negative 1, and we get x is less than or equal to positive 8. So a number is a solution if that number satisfies at least one of those inequalities. If it helps, we can graph the solution, plot the numbers 5 and 8. If x is less than or equal to 5, then those are the numbers at 5 and to the left of 5 on the number line. The other set of numbers, x is less than or equal to 8. So those are the numbers that are at 8 and to the left of 8. So the union of the two sets are just the numbers less than or equal to 8. Okay, so the answer, x is less than or equal to 8. That's the algebraic notation. And the interval notation, negative infinity, comma 8, bracket. That's the algebraic, or sorry, the interval notation. Okay, are there any questions about the compound inequalities? Yes. So if necessary, keep practicing. Make sure you know the difference between the word or and the word and when compound inequalities are involved. Okay, I ran out of exercises from 2.6, but since we have a few minutes, I'll go over the quiz 1. So when writing solutions to a quiz or a test paper, test problem, make sure you put in several steps. If you omit a few steps, then, especially on tests, you probably won't get full credit. So you don't have to go into an immense amount of detail, but at least provide some detail so that it's pretty clear that you understand the process. So this first problem, solve this equation for x, negative 2 times the quantity x minus 4 minus 21 equals negative 3 times the quantity 2x plus 5 plus 14. There's more than one way to start out, but the way that I did it was I began by distributing multiplication by negative 2 on the left-hand side. So negative 2 times the quantity x minus 4 is negative 2x plus 8, because negative 2 times negative 4 is positive 8. And similarly, on the right-hand side, negative 3 times the quantity 2x plus 5. Negative 3 times 2x is negative 6x. And since negative 3 times 5 is negative 15, we subtract 15. Then do the arithmetic. On the left-hand side, we're adding, we have positive 8 minus 21, so that's equivalent to subtracting 13. And on the right-hand side, negative 15 plus 14 is negative 1, so we're subtracting 1. Okay, in the next step, I added 6x to both sides, so we get 4x minus 13 equals negative 1. Then add 13 to both sides, we get 4x equals 12 and x equals 3. Okay, the next problem, number 2, 7 times the quantity 3y minus 2 minus 8 equals 5y plus 26. So first distribute multiplication by 7. 7 times 3y is 21y. And minus 7 times 2 is minus 14, followed by minus 8. And when we simplify minus 14 minus 8, that's the same as subtracting 22. Okay, in the next step, I added 22 to both sides. So we get 21y equals 5y plus 48. And then in the next step, subtract 5y from both sides. And we get 16y equals 48. Divide both sides by 16, we get y equals 3. Okay, on problem 3, start by solving this formula, v equals 1/3 times pi r squared times h. Solve for h. So I'll redo what I did over here. Since we have a factor of 1/3 on the right-hand side, if we start by multiplying by the reciprocal of that, so multiply both sides by 3. So we get 3 times v equals 3 times 1/3 times pi r squared h. 3 times 1/3 is 1, so 3v equals pi r squared times h. Since we're solving for h, all we have to do is divide both sides by pi r squared. So 3v divided by pi r squared equals pi r squared times h divided by pi r squared. Pi divided by pi is 1, r squared divided by r squared is 1. So we just get h equals 3 times v over pi r squared. Note that it's not necessary to convert pi to a decimal number, either in part A or part B. In part B, if you begin with the solution in part A, h equals 3 times v divided by pi r squared, and if v is equal to 12 pi, then we have 3 times 12 pi divided by pi times 3 squared. Well, the pi's cancel. Pi divided by pi, and 36 divided by 9 is 4. So, okay, that's all we have time for. So if you can online type in your first name followed by your last for attendance. So Victor. Carter Hill. Nicholas, Melissa Jones, Anthony Cole. Richard Renz.
Here.
Okay, yeah, and did I miss somebody? No, I got everyone. So that's all for today.
Have a nice day.